Hello, welcome to Unit 9, Lesson 6. Today we'll be solving exponential and logarithmic equations. So in the past we've been using exponential logarithms and we've been going back and forth between the two. And that's something you really need to be comfortable because sometimes it's preferred to have an exponential form, sometimes it's preferred to have it in logarithmic form, and one of those is going to help you solve the equation just a little bit faster. All right, let's go ahead and get started. All right, so as you see here, we have 3x equals 81. Well, if we look at the number 81, it can be broken into 3 and 27, 3 and 9, 3 and 3. So 81 equals 3 to the fourth. So if you have 3x and that equals 3 to the fourth, you can easily see that these two bases are the same, so their exponents will equal each other. Now, mathematically, what you are actually doing is you're taking the log base 3 of both sides, and then that x and the 4 both kicked out to the front, and then they equal each other. But most people don't look at it like that. If the base is the same, exponents equal each other. All right, so here on the next one, we need to write this 8, which is 2 to the third. So we get 2 to the 2x equals 2 to the 3. So then 2x equals 3, x equals 3 over 2. And you can quickly check it, plug that in. 2's canceled, 2 to the 3 does equal 8. All right, let's go ahead and look at some more. All right, so 125 is 5 to the third power. So we're going to do 5 to the 4x minus 7 equals 5 to the third. Bases equal each other. 4x minus 7 equals 3. 4x, add 7 to both sides, get 10. Divide x equals, both even numbers, 5 over 2. All right. Now, 84 and 70 are not multiples of each other. So what we need to do is we need to take the log of 84x and log of 70. Kick the x to the front. And now divide both sides by log 84. And then we get x equals log of 70 divided by log of 84, which this is also equal to log, because of change of bases, base 84 over with a 70 here. And on your calculator, you will get x equals 0.9589. And if you don't know how I got that, you can go look at my previous videos about change of base. All right, let's look at some other examples. All right, so here, same thing. We're going to start out by taking log, or you can take natural log. Sometimes I like to just use natural log because it's one less letter to write, but because the bases themselves do not matter. All right, kick that out to the front. We get x times ln of 3 equals x minus 1 times ln of 2. So that's all now in the front. We need to distribute that. And we get x ln of 2 minus 1 times it ln of 2. Get your x's to one side. and we get x ln of 3 minus x ln of 2 equaling ln of 2. Factor out that x, and you get ln of 3 minus ln of 2. Divide that, and you get ln of 2 over ln of 3 minus ln of 2. And then let's put that in our calculator, and we get 1.7095. And I'm rounding that to 4 decimal places. All right, next one, same thing. We're going to take, log or ln. It does not matter which one you choose, as long as you are using the same base on both sides. Kick that x to the front. Divide by that log of 3.9. And you get x equals log of 48 divided by log of 3.9, which as an exact answer is log base 3.9 of 48. And on our calculator we get 2.8444. When you are putting these in your calculator, if you're not getting these answers on your own, make sure you're closing your parentheses, especially on the TI calculators. All right, let's look at some other examples. So now we're going to be looking at logarithmic equations. So if you notice, we did a lot with the exponential, and we used log to get them. And so now we're going to use exponentials to work through these to get our answers to these logarithmic. So if you have a base of 5 and 4, that equals x. All right. Now, if you're unsure where that's coming from, it's from the notes on the first page that says log a of x equals y, then a to the y equals x. And so if we can switch them between the two forms, sometimes it's easier to make to help us with this. Now, since 5 to the 4th, we get 625. So x equals 625. Now here, this is base e, and we know e and e, we get the exponent, which is 1, which we get 1 here. So this one, when we change the forms, is e to the 1 equals x. So x equals e. So being able to change it from logarithmic to exponential sometimes helps a lot when we're solving these equations. Let's look at some more. So this subtraction right here tells us division. So this would be x plus 20 over x plus 2 equals log base 2 of x. Now, since this log base 2 and this is log base 2, the terms that follow would be set equally to each other. Now, mathematically, what you're doing is you are making this an exponent, and by that rule, this gets kicked out to the front, these cancel out, and you're left with that. Most people don't look at that. Most people see, oh, same log base, we can set the two terms equal to each other. And then we need to solve this. Multiply both sides by x plus 2. Cancels. X plus 20 equals x squared plus 2x. 0 out one side. Subtract x. Subtract 20. And then from here, factor, and we get x plus 5, x minus 4. Set each of those terms equal to 0. And you get x equals negative 5, x equals 4. Now, with logarithmics, you always need to plug them back in. If at any time you get a negative for the logarithmic, it will not be a acceptable solution. So for instance, if you put negative 5 in, you get log base 2 of 15 minus log base 2 of negative 3 equals log base 2 of negative 5. And this negative right here tells you that this is not a solution. So we need to take and make sure that this is an extraneous solution that we do not count. The other one, go ahead and check. Log base 2 of 24 minus log base 2 of 6 equals log base 2 of 4. And 24 minus this 6 means 24 divided by 6, which is 4. So they both equal each other. So this is a good solution. All right, let's look at another example. All right, so we have log base 10 of x plus log of x minus 9. So this means multiplication. So distribute that, you get log of x squared minus 9x equals 1. Now, in the previous examples, I showed how we raise it to the power of. So since this is base 10, we can put a 10 here and a 10 here. And that will turn this bases, take care of each other, leaving x squared minus 9x equaling 10 to the first, which is 10. Now, if you don't want to do it that way, you can always just do it as the change in base forms or switching forms between logarithmic and exponential. But I always like the visual of putting the big thing up here on top as an exponent. Okay, this is a quadratic, so we need to zero out one side, move that 10 over, and now we factor into x minus 10, x plus 1. And again, you can always check these before moving on, especially if you're not good at factoring. I always recommend checking xx, x squared, negative 10 and 1, negative 10. Negative 10 plus 1 gives you negative 9. And then we get x minus 10 equals 0, x plus 1 equals 0. So we get x equals 10 and x equals negative 1. Plug in 10, 10, 10 minus 9, that's a good solution. If you plug in negative 1, in that first one, you will end up with a negative. You get log of negative 1 in that first term. So this is an extraneous solution that we do not count at all. So x equals 10, only a solution. All right, let's look at another example. Okay, so we have subtraction again. So that's going to mean division when we rewrite it as a single log. So x plus 1 on top with x on bottom equaling 2. Base is 8. So I'll put that down here, make that an exponent. So then we get x plus 1 over x equals 8 squared, which is 64. Multiply both sides by x, and you get x plus 1 equals 64x. Now this is linear, so we just need to get our x's to one side. We get 1 equals 63x. Divide both sides by the coefficient of 63. And we get x is equal to 1 over 63. Plug that in, it's positive. Plug it in, it's positive. That works. There is no restriction in the domain for that. All right, let's look at our last example for today. All right, again, this is plus, so that's going to mean multiplication. So that's log of x times x plus 4 equaling log of 12. Now these are both base 10, so we can just set them equally to each other. We get x squared plus 4x equals 12. Quadratic, so 0 out one side. Two numbers that multiply to give you negative 12 and add to give you 4 would be x plus 6, x minus 2. X plus 6 equals 0. X minus 2 equals 0. We get x equals negative 6 and x equals 2. See if either one of those makes it 0. 2 and 2 work. Negative 6 plugged in gives a 0 out here in the front, so that one would be an extraneous solution that we do not count. If you plug 2 in, you get 2 and 6. 2 times 6 does give you 12 as a quick check. All right, that's all I have for you today. Happy studying.